A very warm good morning to one and all present here. Our today's keynote speaker of the session, Dr. Shival Dubey sir. He is Faculty of Mathematics and Autonomous Robotics at Charles University, Czech Republic. Dr. Jyoti Desmukh, Group Director, Sagar Group of Institutions. Dr. Manish Billore, Principal, SISTec Ratibad. Professor Kshitij Yugbodh, Head of the Department, Mechanical Engineering, SISTec Ratibad. Dr. Abhishek Chaube, Organizing Secretary of this conclave, faculty members, and my dear students. I, Dheeraj Kumar Singh, Assistant Professor from Department of Mechanical Engineering, SISTec Ratibad, welcome you all in the National Conclave on Sustainable Smart Cities and Green Energy 2021, organized by Department of Mechanical Engineering, SISTec Ratibad, under Rajiv Gandhi Pradyogiki Vishwavidyalaya, RGPV, in association with DKEMC and Smart City, Bhopal. Objective of this conclave intends to bring together academicians, administrators, and industry experts from the different parts of the country to exchange knowledge and thoughts, focused on latest research and work in the field of smart cities and green energy. Through this conclave, people can get information about what is the concept of smart city and good human life. The students will also get information that after becoming a smart city, what will be the challenges and opportunities for them in future. Before inviting today's keynote speaker of the session, let me give you a brief introduction of him. Dr. Shival Dubey sir is presently working as Faculty of Mathematics and Autonomous Robotics at Charles University, Czech Republic, Europe. He is graduate in automobile engineering, MTech in mechatronics, robotics, and automation engineering, and PhD in agriculture robotics. He is having vast experience in the field of artificial intelligence and smart vehicles. He had also worked for Tata Motors. Now, I would like to request Dr. Shival Dubey sir to share his words of knowledge on the topic smart transport and role of artificial intelligence. Respected sir.
Thank you, Dr. Dheeraj, for these kind words. Okay, so let me start the presentation by sharing my slides onto the screen. During the slide screen, can student have a comment or something like that? Live comment will be enabled.
Pankaj sir. We are on Facebook Live, sir. So students are commenting on Facebook Live directly.
No problem. Can you see my first slide?
Yes,
the
sir.
title slide?
Yes, sir. It is visible.
Okay, fine. Thank you. Thank you, Dr. Dheeraj. Actually, I cannot see the background of your video. So if there's any flicker or something like that into the slides, please let me know, right?
Sure, sir.
Okay. So very welcome to all the students and faculty members who are seeing this webinar today on the smart transportation and role of AI in this national conclave. I would like to thank Dr. Chaube for inviting me over on this prestigious platform. My introduction was already been given by Professor Dheeraj, so I'll not get into that and will straight ahead start with the presentation. So the topic of the presentation is smart transportation and role of AI. The conclave is very focused on the smart city, its development and all those things. So when we talk about smart city, can we say a city will be smart if we place a bunch of Nobel laureate into a city without any other smart facilities, any other thing? So we cannot say that if people are smart and the city facilities are not up to the mark, we cannot say it's a smart city. So when we have the idea of a smart city, when we have the hear the term smart city, there is something, there are some features that comes into our mind. In today's world, if we talk about, we have smartphones, we have smart books, we have smart paper as well. There's a tablet which is coming as thin as paper. You can write it on it, you can save it, save your work on that, you can write just like you are writing on your book. So we have that smart paper as well. So when we talk about things in today's world, all the things we are connecting it with a term called smart. But what is that actually smart is? So when we talk about the smart city, there are few things, few features that a particular area, that a particular city should have when we call it as a smart, right? So there should have various technologies that should go into a particular channel. There are various like in a city, when we call a particular area a city, we have the housing boards, we have the infrastructure, we have the educational infrastructure, we have electric infrastructure, we have roads, we have grocery stores, we have facilitators. So even if we call a city, if we want to call a city smart city, all those aggregators what we have should have that smart feature into that. So we should have a smart environment, we should have a smart economy, we should have smart living, we should have a smart governance, we should have smart people, and one more thing that should we have, that is smart transportation, right? I'll come on to all those parts later on the presentation, but we can have that all these things together can make a city actually smart. So when we talk about the smart city, we'll talk about everything that has to be smart in and around. Like it is not like only the people will have the smartness, otherwise it will not be called a smart city. So a brief glimpse of a smart city, what we called as a smart city should look like this. Like all the facilities what we talk in the first slide, you can have it over here. We have e-services, like the services of anything, government, health, medical, infrastructure, tourism, and all those should have the e-services. Like we have all those things on hand via internet. Environmental friendly design building. Friendly design building means the building that are actually energy efficient, like not today what we have, like there are some buildings, or there are some infrastructures where we still need lighting in the day, even if it is sunny outside. So we should work on this particular part of smart buildings, or we can call it as environmental friendly buildings, or energy saving buildings, right? Then we should have the water and gas distribution management and leak detection. Like in India, if we talk about the distribution of water and gas, so we have approximately like 80-85% of the water to be delivered by the pipelines till now, even after 70-75% years after the independence, we have that particular system. But the gas distribution, or the LPG, what we called as the gas for household purposes, that distribution is only done by, like, majorly it is done by the bottled gases. So we have so many accidents happening in that particular thing. In Gujarat or in Maharashtra, these are the two or three states which they are now going towards the piped gas distribution system, right? So we should have a smart water and gas distribution system, and an early leak detection system as well, so that whenever there are leak or there are some emergency into the system, we can beforehand we can stop that particular things to go into a disaster. Then we should have a metering management and demand response. That metering management is connected with the electricity, or we call as electrical distribution system. It's a part of electrical distribution system. That means if you have a lower demand, then you should have the metering. You will provide a lower. You should get the lower exact amount of electricity to your substations, where like in winters, when we don't use our fans and ACs, unlike in summer when we have higher load supply and frequent trip to the power failure, then this particular metering management and demand response should get into the action. We have smart houses, we have the electric vehicle infrastructure, we should have emergency and disaster management system, like the urban flooding. If we have excess of rain coming onto in the raining season, we should have that particular system so that we can flood the water to the either to the collectors or to the underground channels. We should have that. We should have alternate energy system apart from the conventional source of energy, whether it's electrical energy, whether it's electricity or the demand for the petrol or diesel. That doesn't matter. We should have alternate energy system with the help of like wind energy, solar panels, offshore panels, tidal wave energy, and all that. We should have a public safety system where we can, where the public can have freedom of their free expressions, and we should have a multimodal intelligent transportation. So we'll focus today on this particular point. A multimodal intelligent transport system. If we talk about that, it's a complete conjecture of land, air, and water transportation system. If we talk about multimodal intelligent system, all these things are connected. All these things are connected. If we say the road transportation is connected with the water transportation is connected with the air transportation, and we have a live feedback on our website, like the delays, the early run, or the timetables, and all those things what we have. If I talk about my experience over here in Prague, the Prague has one of the best multimodal transportation system in the world, right? We have the trams on road. We have the ferries in a river. There's one river which runs through the center of the Prague. We call it Vltava. In the Vltava river, we have a ferry system. Then we have a train network connected. Then we have the bus network connected. Then we have the flight network connected, and all those things, that information, whether you're talking about the tram, whether you talk about the ferry, whether you talk about the bus, whether you talk about the trains, all that information comes handy on a particular app. We have an app called PID over here, Prague Integrated Department of Transportation. We call it PID. So we have an app called PID, and you find each and every detail of every tram number going from one place to another, or starting from where it is ending from where, and each time, and the time it will be marked on each station it will reach. So this is what we have, the multimodal transportation system over here. Like we have to pay a yearly fee, and we can use any means of transportation, any means of public transportation for the rest of the year. Whether it's water transport, we go into the ferry, whether we go into the tram, whether we go into the buses, whether we go into the trains, each and everything is free over there. So this is what we call the multimodal system, and this is common to each and every city in the Europe. Prague is one of the best because they are using it since 1700s. So it is one of the best. But in Europe, each and every city has that particular system. So that is what we are going towards, the multimodal transportation system. That is what we call it, the multimodal. Right? There are the models are differ from one part to another. So if we talk about the key components in the smart city planning, we have the urban planning. The urban planning consists of the planning of people, where the your population is going to live actually, because the area where the population is going to live, you cannot have any other things. But there are few things that should be close by. You should have a close by daily shopping malls or something like that, grocery shop or something like that. You should have the nearest your transportation system. If we talk about the public transport, you should have all the public transport accessible. If we talk about the personal transport, you should have that capacity of your personal parking of cars, maybe in front or underground of your buildings, right? So urban planning should be there. We talk about the system design and management operation. Then we have 2 points: the technologies and urban infrastructure, this smart sensing and computing. That we'll cover in broader perspective in the coming slides. All these things, all these points come like merge into a particular part, that is what we call as a urban multi-modal system for high density megacities. Like high density megacities, if we talk about, so in MP, if we talk about, then we have Bhopal, we have Indore, Gwalior and Jabalpur, what we call as high density megacities, and there are few others, obviously, because I'm not in touch from there too long time. There must be some other cities as well which are coming over as a high density megacities, but in my time, those are the 4 cities that we called as a mega cities in particular MP. Right, so we can have that particular smart performance of the things, smart travel behavior of the people, like smart travel behavior. We talk about smart travel behavior. We should have for short distance travel, for medium distance travel, for long distance travel. That things can be done. We can neutralize the carbon dioxide generation. Each and everything we see in the universe, each and every thing generate their carbon footprints, whether it's a vehicle, whether it's a building, whether it's equipments or any other thing, each and everything generate carbon footprint. So in order to reduce those carbon footprint, the smart city planning is something that is very much important. And it is not only the part of the what you can say civil engineer, that the planning of the cities is his job. Each and every engineering stream is coming together onto this particular part, whether you talk about the water engineering, water resource engineering, whether you talk about electrical engineering, whether you talk about power system engineering, whether you talk about mechatronics, mechanical, automobile, maybe computer science, because controlling all this on a particular chamber, on a particular room, you should have a computer engineer on board. Creating all those electronic circuit, you should have an electronic engineer on board. But transferring the power, electrical power, and sensing its need for the people, you should have electrical engineer, power distribution engineer, power system engineer. So all those engineering streams what we have now, all those engineering streams are very much important for the smart city planning. It's not a single person job, it's not a single stream job that he can do that. Like a civil engineer, because he's eligible for planning the cities, or planning a particular house, or mapping a particular house, he should do it. Each and every one of the person has to do it. Now we talk about a topic that is smart transportation planning and performance. So what is smart transportation planning that we can see it over here? Right, starting from the topmost left, we should have an adaptive signal control. What is adaptive signal control? Is like that. I'm again taking the example of where I'm living right now in Prague. We have the adaptive signal control. That means on a square, if we have a signal and we see that the right lane or the left lane are free, and there are people who are waiting for their turn on the footpath, turning the foot signal or the walk signal to turn into green, and there are no other traffic on board. So the timer of your traffic signal should get reduced, and it will allow more time for the commuters or the pedestrians to cross the road as compared to the other times when we have less pedestrians on board and higher vehicles running on the road. So that is what we call adaptive signal control. The signals or the traffic management system, it will adapt accordingly to the traffic conditions, or on the basis of what time of the day that particular signal is being used, right? Each and every signal, not about the complete system, each and every signal. Then this is what very important thing is the second part, bicycle sharing system. We have a bicycle sharing system over here. We have the bicycle. If you might have visited one of the, or if you may visit one of the cities in the Central Europe or the Eastern Europe, you'll find this system very integrative, right? We have bicycle sharing system. You see, there are certain points on the road or the footpath where we have a bicycle stand, dedicated bicycle stands. On those bicycle stands, you will have an app on your mobile phone. You'll put that, you start that app, you pay some price, you put that app onto the lock of the bicycle will open on its own. The lock of the bicycle will open on its own. Then you take that bicycle around the city at any point. There are certain dedicated point where you can drop off your bicycle. You again put your app on the lock. The lock will close, and the time you were running the bicycle, it will be calculated and depend on per minute basis or per hour basis or whatever the basis of that particular pricing is. On that particular pricing, your ATM card or your bank account will automatically deduct it for that particular part. So that is what we have, the bicycle sharing system. We have better mobility and less congestion. Better mobility means the real-time information of each and everything, like I'm talking about earlier. In the public transportation system here in Prague, we have the minutes and the second of each and every public transport commute to be there onto the station. If the PID is saying that the tram number 13 or tram number 18 is coming on 14:20 or 14:23, the particular tram will come on that particular time on a station, right? Then we have V2V or V2I technologies. V2V is what we call as vehicle-to-vehicle communication, and V2I is what we call as a vehicle-to-individual communication technology. If we talk about vehicle-to-vehicle communication, that means when your car is running on the road, that car will have the knowledge like who else is driving or who else is walking or who else is going around that particular car. So it will communicate with other cars. Each of the car will have some radio signals or some communication devices inbuilt into them, and they will have the communication attached. Each and every car can communicate with each other, and they have that particular safe distances, like who is going, what car, what bus, what truck is going beside him or in front of him or back of him or side of him, left side or right side. So we can create an area where the happenings of those like accidents will be greatly reduced. And vehicle to individual technologies, that means the information on the dashboard of the driver, like who is coming onto both sides. We know as an automobile engineer or as a driver, when we ride the bicycles or when we ride the motorcycle or when we ride the cars, there are certain points we call as blackout points where we don't see what it is coming from behind or who's going to overtake from the right side or the left side. So those are called blackout points where we don't see a particular vehicle. There are obviously there are certain points in the, even if you adjust your rear view mirror, you will have those blackout points, right? So when you have those blackout points, if you want to take a sudden turn, or there are people who don't worry about like before turning, they don't like to turn on their indicators, or they turn on wrong indicator before moving to left or right. So that particular instances will be greatly reduced if we have the V2I technology. The dashboard of the driver will have each and every information on board, like who's coming from behind, and he can act on that. Automobile sharing is one of the most important part that we should have take into consideration. Like if I take a live example, so let's talk about the faculty who are coming to the Sagar Institute at Ratibad. There are few faculties obviously who are coming by buses or something like that, by the public transportation system, but a majority chunk of the faculty people, they are coming by their own cars, right? Their own car, their own motorcycle. Most of the cars are empty. Maybe a faculty or two will coming in a car of 4, right? Or if we have 1,000 faculty members in the university, then we have approximately 500 to 600 cars on board, right? Like if a car has a capacity of 4, can we have a system called pooling, where we can where a person who's living in a nearby society, or who's living in an area where there are more than 2 or 3 faculty members are residing, so they can share a particular car, right? So they can share a particular car. So instead of 3 cars or 4 cars in a parking lot, we have a 1 car in the parking lot. That will drastically reduce the carbon footprint. Point number 1, it will reduce the load of the vehicle fuel onto the owner or the or onto the driver or whosoever is driving that car. then that can be applied to the students as well. If majority of the students are coming by the buses, the college, university buses, that is fine. But there are few students who like to come by their own vehicle, right? So they can share their vehicles, and instead of the parking, you see that particular parking full all the time, you might have get some of the parking spaces at that particular point, because obviously the parking spaces are limited, and we have the ultimate number of vehicles growing into the market nowadays, right? Next point is what I generally do not see in most of the countries, like walking and cycling facilities. Right now, there are few cities in India as well. They are working on that particular part, but most of the walking or cycling paths are being taken over by the street vendors. They are not like, I do not see any people walking on that. Especially when I saw that in Mathura, when I saw that in Vrindavan, or I saw that in Lucknow, there are some dedicated cycling paths are there, there dedicated walking paths are there. So I see each and every footpath or a cycling paths are being covered by the street vendors. But we have here now what we have broad footpaths or the cycle paths onto the system here in Europe, right? So these facility will add an extra bit of relaxation into the mind of the people, right? The one thing that I see when I first came to Europe is that like when you cross a road in India, when we cross a road, in most of the time we have to see on both of the sides, and then we cross, right? Like even if you are crossing through a zebra crossing, a zebra path, if you are crossing through the zebra path, you have to take that thing into consideration, whether a vehicle is going to stop or not. You have in that double mind, right? But what I see here in Prague, I don't know about the rest of the Europe, what they are like. Here in Prague, if a person sees in a car, if he's in a car and he see a pedestrian is crossing by, they ultimately going to stop before that zebra crossing, and they allow even if they are in a very hurry, they allow the pedestrians to go first. This is in the rule book of the driving rule book of your in the Prague system, right? We have certain disruptions as well. Uncertainties in disrupted condition, whether it's a climate disruption, or whether it's a natural disruption or a man-made disruption. There are few disruptions, and we should have that facility to handle that disruption without creating a major chaos in the city planning, right? So it's a very important part of the city planning that we have that particular alternates all the time to get that particular part. And obviously the smart vehicles, right? The smart vehicles, if we say smart vehicle, the smart vehicle is something which have a latest communication technology on its part, right? Earlier when we say a vehicle or a car, we think about a car. We have mechanical gear lever, we have mechanical controls, we have all those things are mechanical nature, connected to the links and all. But slowly and steady, the electronics is coming into the vehicle, and it has taken over most of the part of the vehicle. We have power steering, we have power brakes, we have power gear shifter levers, we have automatic system, and so on. And now in the third phase, the artificial intelligence is also coming into that particular part. So apart from the electronics, or if we say along with the electronics and the mechanical, the artificial intelligence or software intelligence is taken over the human intelligence in most of the operations of vehicle, right? You might have heard of a term called cruise control. In the cruise control, you switch on you just put a switch, and that switch will take over the car. It will cruise your vehicle on a speed of on some limited speed, maybe 45 km/h, maybe 50 km/h, right? If you are feeling sleepy, it will have an eye on you. If you are feeling sleepy, it will shake your seat. It will ultimately stop a car on one side of the road. You might have heard of a better term when you travel by air, that is called autopilot, right? So what is autopilot? That autopilot is same as the cruise control. The pilot will take the aircraft into the air, and after taking the aircraft into the air, when they are at the cruising altitude, maybe around 27 to 35,000 feet above in the air, they have on that cruising altitude, then the pilot switch on the autopilot that will take over the rest of the path, whether it's a 13-hour flight, 14-hour flight, 18-hour flight, that doesn't matter. The autopilot will take to the rest of the path, and the pilot will ultimately take the handover when it is coming to the when the airport is when the aircraft is landing again onto the destination airport. So this is what we call we have the effect of AI or artificial intelligence into the sea. So we have this infrastructure in the central picture. You can see it about that. We have each and everything, like most of the things you see nowadays in our cities. We have greater Wi-Fi signal. We have 4Gs and 5Gs coming into our world. We have a good cellular signals, but there are certain areas. Still, there are certain areas we have weak signals or phone. Almost all of us have at least one smartphone. Maybe some of you are privileged to have 2 or 3, but we have at least everyone have one or at least one smartphone in our hand. We have CCTV cameras, not like all the cities have that, but there are certain cities we have CCTV cameras. Even if we talk about not on the streets, each and every shop, each and every mall, each and maybe most of the homes, they have the CCTV camera on board. We have wireless sensors in order to throw the data from one place to another. The homes are Wi-Fi, the colleges are Wi-Fi, the universities are Wi-Fi, even the cars nowadays are Wi-Fi. We have the malls Wi-Fi, we have the Wi-Fi on the roads as well. In a certain premises of the city, we have the wireless signals, and also this is what we have, the traffic detectors. The traffic detector is one of the important part we do not have in India right now. Maybe Delhi, Gurgaon, or Mumbai, those cities have that. So we have a traffic detector in place. And we have vehicle tracking devices. So vehicle tracking devices in most of the rented cars or something or taxis, you have that particular feature into that, right? You can track your particular vehicle, like those sharing taxis companies. They are giving that. They have the vehicle tracking devices, and on your mobile phone, on their app, Ola or Uber app, you can track what is the distance of the vehicle when it is coming to you or when it is going to drop you to the destination. You can share your location as well to that thing. So we have that vehicle tracking devices. We have autonomous self-driving vehicles. You have heard of Google car or something like that in the recent times. Those are the cars which are not driven by the driver. They are moving on their own. They have a few sensors attached on their body, like ultrasonic sensor or the radar or laser range finders or something like that. A mapper also. On the top of the car, you can see left hand side top photo. You can see the laser range finder or the mapper is attached at the top of the vehicle, so it will map the environment accordingly. It's a learning phase. So then we have the electric vehicle charging infrastructure. That infrastructure is still we should have in India. We must have that particular structure, but it will take time, right? So we should have that electric vehicle charging infrastructure. I saw one or two, I saw many stations here in Prague. We have there are vehicles who are lined up for getting charged, and there are a few vehicles they are charging at the station. We have the speed map panel. That is very much important part. You can see on 2 poles at the center of the road. They have a panel which is giving the speed map, like at what speed you can go on a particular road that is being digitally driven on that particular part. So in most of the time when there is no rush or there is small usage of vehicle, you can have greater vehicle speed. And when there are rush hours, like in the morning or in the evening, when people are going to or coming back from the office, you can have a lower speeds, so that to avoid accidents or getting injured or like that. So we should have intelligent speed map panels, real-time information system. We see all those things on the railway stations and airports nowadays, but that should also be get actual real time. We do not have the actual real time information at our disposal most of the time. Like if it is saying the train is coming at 2:30, it might come at 2:45 or 2:50, but that will not be displayed on the panel. And we should have the like journey time indicator. We have those journey time indicator in the highways nowadays. So what does that mean? We should have an indicator that will give us the actual reading from the destination, not those boards written a long time ago on those highways, right? So if we talk about the concepts, what are the key concepts that we have? So we have the automated traffic, we have the automated traffic management system, we have the automated vehicle location, we have the car and bike sharing, we have the driverless cars. All those things you already have seen. We have nowadays, we have this important part, what we call as e-tolls and electronic roads. The time there are few time when we there are the vehicle have the fastags on their installed on their windshields. Like right now we have that particular thing. So e-tolls are taking the pace in India nowadays. And electronic road pricing, it's a very unique concept. I saw that when you travel, might be some of you from Delhi or somewhere, you might have traveled on those two expressways called Eastern Peripheral Highway and Western Peripheral Highway, right? There are two roads that goes around the Ghaziabad to the Mathura. It is connected to the Noida and Ghaziabad. I don't know. These are the two areas they connected, and like they have the pricing according to the distance you travel on that particular road. Like in normal highways, what we have a toll booth. On that toll booth, you have to pay a price, whether you are coming like you are entering late or you are exiting early. That doesn't matter. What matters is you have to pay the full price of the road, full price of the usage of the road, even if you're not using it, right? But that electronic road pricing system, what it is done, like they are taking you the toll of the distance you are going to cover. They have entry locations 1, 2, 3, 4, 5, and they have exit location 1, 2, 3, 4, 5. So you are not paying the toll at the start of the road. They'll give you a paper on which your time of entry or gate location will be written, and when you exit the highway, you have to get that particular slip attached on the exit station, and they'll charge you accordingly. They have a few pricing panels and they charge you according to that, right? So like so if we talk about the integrated system, integrated multimodal transportation system, so it will look something like this. What I'm talking about earlier in my first or second slide, I'm talking about this. You can see this broad picture over here, right? I'm talking about this. So what is what this will have? We have the satellite communication, we have the land broadcasting, we have mobile towers, we have travel assistance. So you can see this is intermodal communication, where the train, you can see a ferry in the water, you can see a flight over there, you can see there are a few vehicles on the road. All those things are connected through a central command station, and that central command station will take care of those, right? You can see the toll collections, automatic toll collection on that. You can see behind that toll you have the safety system, because ahead there is a pitch, and in order to avoid that pitch, you have the automatic safety system. That safety system will trigger a signal, and the signal will be flash in your dashboard, so that it will say that ahead at 100 meter or 200 meter or 500 meter there is a left or right turn. You have to take that right turn, and you have to reduce your speed, right? So instead of putting a man over there and manning that particular area of accident, you have that automatic signal into that place, right? You must have the adaptive cruise control. You can see at the left bottom part, we have the adaptive cruise control. That adaptive cruise control is what we can say if your car is running at a speed of 60 km per hour, and you have a school coming ahead. The limit of the speed limit for the school is about 20 km or 30 km per hour. Then your vehicle will automatically get a ping on its system that there's a school ahead on 200 or 300 meter, and you have to reduce your speed from 60 to 20 or 30 km per hour. That is what we call as the adaptive cruise control. If you are driving, then it will be flash on the board. If you are not driving, the cruise control is driving, then the cruise control will automatically take that particular particular thing into its computer. So this is what internal, you can say, the multi-modal system, transportation system. This is how it is works, right? Like how the if we talk about the vehicular system or smart vehicles or smart transportation, how this system flows into the network. So the system will flow we have the in-vehicle system. This is the sensors in your car. You have the microprocessor, you have the microcontroller. Right now we have the electronic control units in the car, and those are also getting advanced. Those are microprocessors that have a few thousand line of codes inbuilt into them, and they'll control each and everything. They'll control the oxygen sensor, they'll control the wall timing, they'll control the petrol or the fuel going into the cylinder, they'll control the ignition timing, they'll control the ignition delays, they control the tire pressure, they monitor the tire pressure, they control the windscreen wipers and all those things. So each and every sensor part, each and every mechanical part of the car is now sensorized, and those sensors are being monitored by that a particular small computer placed into the car. That is what we call as ECU, or electronic control unit, or the central control unit, right? That electronic control unit, what it is maintaining in the car, it has communicated to the vehicle-to-vehicle system, what we call as V2V, right? Vehicle-to-vehicle system, you can see it over there. The two vehicles are communicating with each other, right? So they communicate about the distance. If the front vehicle is putting a pedal on the gas, it is moving ahead, and it will give indication to the back vehicle that yes, I am going ahead, I am moving forward, I am going fast. If it is putting its pedal on the brake, so it will tell the other vehicle to get stopped, so that it will not come and hit from the back, that I am going to stop, my speed is getting reduced, or so on. So these are the vehicle to vehicle communication system. And then we have the vehicle to infrastructure system. The infrastructure system is communicating with the speed mappers, automatic speed mappers, communicating with the distance mappers, communicating with the electronic toll booths, communicating with the electronic signals, communicating with the other electronic or you can say automated system on the roads. So that is what we call as a vehicle to infrastructure systems. If we talk about ITS, ITS will have these three important parts. We have the vehicle technology. In the vehicle technology, we have the smart cars, we have the driverless cars, and we have the connected car, right? All those things we have already discussed. The automatic traffic management system, the flow of the traffic according to the rush hour of the roads, the e-tolls, automatic deduction of tolls, like we have the SISTec now in the vehicle installed. We have the ERP, the pricing of the usage of the road according to the distance you traveled. We have the travel information system. What should be the speed, how much distance you should travel, where is the next you can say the petrol bunk, or you can say the refreshment system, where you'll get all those things, where you get the water, and all those are travel information system. And we have the route guidance system. We can have the GPS connected to the information panel, and that GPS will give the location to the driver, or with the help of navigation system or the global positioning system into the vehicle. Now it's coming to a very important conclusion, like what is AI? If we say all these things are connected, all these things are giving us the information, all these things are making our life easier, but there has to be some magic that is working around them, right? So what is that magic that is working around that? It is not like a magic with some wand or something like that. It's a magic of the computer codes, right? We call it artificial intelligence, right? The name itself give you a brief a tickle in your head, artificial intelligence, right? So there are two types of intelligence, what we call as, one is called human intelligence, and other is called artificial intelligence, right? So human intelligence is what we have given by us from the Almighty God, and the artificial intelligence is what we have created in our system in order to match what the God has created a few thousand years ago in our mind. We are trying to create it right now, right? So we have the artificial intelligence, something like we give a signal and we give an input, and according to that particular input, the same machine will perform different tasks, right? So what does it mean? If I have a machine, if I have a computer, and I'm giving a input of say open Word, it will open the MS Word. If I'm saying play movie, it will start play movie. But those input will not come directly from the keypad or mouse. It can either come from my hand gestures. It can come from my voice. It can come from my mind. There are few computers in the area where the people are controlling with their mind and all what the thought they are having. The same thought has been picked up by the computers, and they work according to that, right? So this is what we have the artificial intelligence into system. There are few things that make AI work. There are a set of tools that make the AI work. That is we have the search and optimization. We have the logics, or what we call as the problem solving. Like we have the mathematics play a very important role into that. Probability and uncertainty reasoning. We have the statistical learning methods and classifiers. We have the neural network, right? You might have heard saying the doctors most of the time in the mind, we have a set of neurons running here and there in our brain, right? So in the same fashion, what we have the neurons in the brain, some crores and lakhs or lakhs of crores of neurons in the brain running one point to another point at each instances. We have the same neural network into the artificial neural network into the system plane. And obviously there are certain programming languages that will tell that artificial intelligence what to do, right? Just like when a person born, he doesn't know, he or she doesn't know anything about the world, right? From getting the feedback from the parents, from getting the feedback from the environment, from getting the feedback from its own experiences, he get those things mapped into his brain, right? If if your parents regularly tell you that this thing is not good, that thing is not good, this thing is good, you have to do this thing. We have our visual feedback from the videos and the information available on the net that you have to do that thing, a human has to do that thing, we can have to that thing. We should have that thing in our mind when we do a certain task. All those things are getting mapped into our brain, right? So that is what we call as a programming language, right? In computer, when we tell a computer like you have to do this particular set of things running in your mind when I give this particular input, that is the thing that tells the computer about, that is called programming language. All all those things, all those persons, all those information we are getting from the environment is the programming language for our mind, right? The experiences, the parents informing us about certain things, the friends informing about certain things, good or bad, the parents telling us about something good or bad, the visual feedback we are getting from the internet, good or bad. All those things are the programming that is mapping into our mind. So similarly, the AI system should also have some programming language that is done by its user. So if we talk about the automotive systems, because this is smart transportation, if we talk about the automotive system, the AI is very much into the automotive nowadays, right? In each and every sector, if we talk about each and every sector, whether you talk about the manufacturing, we talk about transportation, you talk about services, each and every part of the automotive industry, we have the artificial intelligence into work. So I have categorized into some category, like we have them in the manufacturing, from the design to the supply chain management, supply chain of the parts, or the management of the vendors. Those are giving part to the production, to the post-production. It is being, the AI is everywhere. Like we make some designs, that design being validated by some computer, we put some load or something like that, and that design is being validated by some computer software. That is what we have in the AI. The vendor management system, the HRs used nowadays, or the industry use nowadays are also the supply chain. Vendor management system is in the supply chain. Then we have the production. Obviously, in the production, we have artificial intelligence in the production. The productions are controlled by robotic manipulator. They are controlled by automatic conveyors. They are controlled by automatic material feeding management systems. So this is what AI is. And the post-production, obviously. Transportation, if we talk about, so we have driver assist systems, that is what we call as the cruise control. We have autonomous driving without human control. We have cloud computing, the control of ECU and getting feedback from the environment. We have the driver risk assessment. The driving school and authorities use this particular system to assess the risk of drivers. Then we have driver monitoring system, like the companies, taxi sharing companies, they use this driver monitoring system so that they can put a tab on their drivers or the users of their cars or something like that. In services, we have predictive maintenance. The predictive maintenance is like if you bought a car, right? And today, on 24th of September 2020, you have gone for your car servicing, right? So automatically after, or maybe 6 months or 7 months or 8 months or 3 months or every quarter or every half yearly, you will get ping on your mobile or your email IDs like your predictive maintenance is due, your predictive maintenance due, your maintenance due. So there is not a person there who's doing that particular part, right? All those particular part services are being done by the artificial intelligence agents that is being put there as a bot, right? And then we have the insurances, like nowadays. In earlier days, we have an insurance agent coming to our houses who will do the insurance for our vehicle. Our fathers and our grandfathers do this all the time. They have an insurance agent on board. They give some information to them. He took some money and all those things being done by the insurance agent. Now we have the insurance online, right? We have like paisabazaar.com or policybazaar.com. We have the facilities like CoverFox and all those insurance companies. We have all those insurance companies are running on the website alone. There is not a single person who's controlling that particular website. Whatever input you are giving about your car, whether you are giving it's your car age, you are giving your car kilometers, you are giving your whether you have taken the claim in the earlier year or not, based on all these inputs you are giving, it will calculate the insurance amount and it will give you offers on that particular part, right? So this is what the AI in this system, right? Now, if we talk about the various level of AI, right? There are different levels of AI if we talk about. So there are 5 or 6 levels as per the Society of Automotive Engineers. There are 6 levels of automation, right? Those 6 levels starting from level 0 to level 5. If we talk about level 0, it's called no automation. There is no automation at level 0. The complete control is the human control or the mechanical control, as we talk about, right? The controlling through linkages and mechanical steering and all those things are called no automation. At level 1, we have the hands-on automation. Like the hands-on automation is what we call as driver assistance system, right? We have the driver assistance, like it will guide you through the parking. There are few cars which in the earlier system where their first rear parking sensor was installed, and that is what we call as the driver assistance system, or the side cameras are installed to give the driver assistance to put your car into an area where there is a small gap on both the sides or at the back, right? So that is what we call as a level 1 of automation. Level 2 of automation is hands-off. Hands-off means your partial automation or your cruise control, right? In cruise control, it is not like you can sleep in your vehicle, right? Even if you put your vehicle into the cruise control, you must have to wake up, right? You have to see how the car is performing, and if there is any condition or situation where the car cannot handle, it will give you to that particular part, right? So this is what we have, the partial automation, and cruise control is what we call as the level 2 of automation. Then we have the level 3 of automation, which is called eyes off. First off, hands off in cruise control. Then we have the eyes off, or we can say the vehicle is moving on their own, and you can sleep on board the car, right? That is what we call as a conditional automation. Then in level 4 we have the mind off, right? The mind off means even if your eyes are off, you in your mind you have like the vehicle is driving on its own. Then we have the mind off, like the driverless cars. Right? In London airport, when you go to Heathrow Airport at the London, there are pods which are moving automatic without any assistant, without any driver, without anything. The seating capacity of 4. They are working since 2011. So they have the seating capacity of 4, and those pods will move around. They'll pick up the 4 passengers from the terminal, and they'll go around and leave those passengers and again come back to the terminal to pick the things up. So that is what we call as a mind off. And in the last, we have the full control. The automation will have the full control, and what we call as the full automation is the complete car that is being governed by the automation. You don't either have to switch on the car. You don't have to get the keys to get into the car. The car will come to you automatically. You don't have to park the car. The car will come to you automatically. They'll open the door automatically. You'll get inside. You just put a pin point on a particular map or something like that. The car will take you to that particular. That is a level 5 of automation. We have not reached there yet. So if we talk about the maturity level of the industry in comparison to AI adoption, so we see automotive is still at the center of that particular maturity, right? We are not the strugglers or beginners, and we are not the aspirationals or matured, right? There are few industries which are matured, that is financial services and ICT. Like you see the insurance companies and all, insurance companies, travel insurance, medical insurance, ticketing systems, all those companies, they are called matured industry. They have highest level of automation. Then we have the aspirational industry like health sciences, healthcare, life sciences, retail, big mart, mega mart, or your big bazaar, your D mart, your Reliance store. They have higher next level of automation into that, right? So they are aspirational industry. In the mechanical industries are somewhere at the middle. They are called new adopters. We have the automotive and mechanical industries into that. Beginners will be oil and gas and chemical, because it is still involved a risk of human lives. So we have we cannot directly move on to the highest level of automation into that. So we put them into the beginners. And we have the strugglers like agriculture. You have to still drive the tractor. You have to still get your seeds sow into the farms and on. There is no automation into that, right? If we talk about the AI in automotive value chain, so what is the value chain we talk about? There are three main parts in that value chain: is manufacturing, transportation, and services. We already discussed about this in the manufacturing, in the transportation, or in the services. What is the role of AI in that part? This is somewhat important thing is you can see the impact of artificial intelligence in the market, right? So we have the data from 2020, we have the data for predictive data for 2025, and we have the predictive data for 2030. You can see it over here in the 2019. You cannot see the automation beyond level 3, right? And that is also the level 1 is the highest, 89%. Level 2 is 11%, and level 3 is somewhat at 0.01%. You can see it over there, right? In 2025, what we have predicted is level 4 and level 5 will go into the market. The level 1 will slightly be majorly decrease from 89% to 30%. The level 2 will increase from 11 to 41%, and we have the level 3 and above, like level 3 and level 4 and 5 to approximately 29, but to cover the 29% of the market. That is what we are seeing right now, right? If you see a car, if you see new cars right now, they have huge load of electronic system installed into them, right? If you open a door, they'll say your door is open. If you close the door, they'll say the door is closed. Even you have the automatic climate control feature into the cars. You have heated seats. Before that, when you there's a point not far in 2006, 7, 5 or 7, 6 or 7, when we start our vehicle into the in winter season, we have to put the choke. We have to hit the engine before getting off the vehicle onto the road. But right now you don't see those things, right? So in approximately 15 years, the level of automation goes from level 0 to at least level 2 or level 3, what we are facing right now in the industry market, right? And by 2030, if we talk about the prediction for the 2030 is like level 3 to level 3 and level 4 and 5 will approximately take over to the 60% of the market, right? You can see it over there, 41% and 90%. So it's coming now. It's coming now. If we talk about the European countries, the level 3, they have already crossed the level 3 condition, right? They are coming to level 4 and level 5. They are working hard for level 4 and level 5, because the level 4 and level 5 for it's not only the vehicle that has to be maintained. It's the complete infrastructure. I'm talking from the start. It's not only a one-man job. It's a complete infrastructure has to be renewed if you are getting some changes on board from your regular life, right. So you need to have that particular full infrastructure into place for level 4 and level 5, you strictly have to follow the traffic system, because the driver is not there into the car. You cannot cross the road just like that. You have to wait for the signal. If you are maybe crossing the road without any signal or something, maybe the car will stop at a certain point, but there are few cases, maybe 2 or 3% chances are there the car will hit you, right? Because at that particular point the automation may or may not work. It's obviously it's a machine, right? So at one point, so each and everybody in that particular environment has to contribute its share of knowledge, its share of point in making that particular thing happening, right? So the impact of AI, we can see it over here. Level 4 and level 5 is coming to hit us a very big time. In that level, in 2019, we have approximately 33 million vehicles in the market, which goes to 65 million by 2025, or maybe sooner, maybe not 2025. We do not have to wait till 2025 because of this corona and all. Each and everybody is getting their own vehicle. They do not want to share a vehicle among them. So we have higher number of vehicles right now, and by 2030, maybe not 2030, sooner will be, we will cross that 80 million mark for the vehicles, right? So this is how it will be done. Now we have the technology providers and collaborations. You can, being a student, there's a huge opportunity in this particular market, right? In AI, or if we talk about the mechatronic system, each and every one, whether you are a computer science student, or you are an electronics student, or electrical students, or automobile, or mechatronic, mechanical, AI or mechatronic, or amalgamation of mechanical and electronics is something what we are seeing into the future. If you want to get something in the near future, you must have another skill set in your system, in your study, right? You cannot rely on a single source. Electronic engineer cannot rely on the electronic itself. He has to get the programming knowledge. He has to get the certain feel of the how a particular system work autonomously. A mechanical or a automotive engineer should have the feel how that particular ECU works, how we can improve the life of a particular person by getting into the electronic system, how those electronic system are maintaining that car very much. We have nowadays, we have smart suspension system as well. Earlier the suspensions are mechanical in nature. Now we have smart suspensions which will alter their coil length and their coil stiffness according to the road they are moving on, right? So the technology has like put itself into that much deep into the system that you should have that kind of knowledge into that, right? So we have the Google, Vimo, maybe most of the companies you have heard of. In India, we have KPIT and LN Technology Services that is working into that particular part. You might have heard of KPIT. KPIT is responsible for they're responsible for creating or devising electronics into the cars. They devise for power steering, they devise for ECUs, they devise for your infotainment system, inbuilt GPS system, inbuilt navigation system, and all those things are done by the KPIT. We have the L&T Technology Services that is working on smart vehicle, and they have the collaborated with various smart city planners to get the feel of what smart city look like, and they are very much contributing into that. BMW has already collaborated with the Tencent, it's a Chinese company, to develop a level 3 car by 2021, or it has already been developed in 2021, maybe by the end, because of this recent corona thing has happened. So maybe 2021 or earlier 2022, it has not come till now in the market. Mercedes-Benz, it is already working with the Bosch. Bosch is, we already know, the Bosch is one of the company that is working into the PLCs and pneumatics and hydraulic system into work. So they are developing a level 4 and level 5 autonomous vehicle, but it will take a long time. There's a long way that will go into this, right? So we have things working. Apart from these companies, there are many small vendor companies are there. Those companies are working on that particular part. Even I'll say to all those engineers, all those students who are working on, who are currently studying in the final year or final like third year into their studies, to go for these kind of projects in their final semester or final year, so that they can have some feel of what the actual industries are doing. I understand that as a student we don't have the hand on each and every technology available in the market, but at least we can try, right? You go for the programming languages. Python is coming into the picture very much in the recent days. So you can go for the Python, you can go for the Java, you can go for the machine learning part. It's a very much important thing coming up into the recent market. And believe me that machine learning will take over to the automotive industry very soon. Very soon the machine learning will take over the automotive industry. So get into the machine learning part. There are so many videos and other things available on the YouTube or some separate websites. So you can have them on the free as well. Get some feel on the machine learning. Get yourself into some multi dimension areas where you can work on either mechanical or electronic as well. You can work on automotive or computer science as well, and all those things, right? So thank you. This is it, I suppose. If I not overshoot the time, this is it. Professor Dheeraj.
Thank you so much, sir, for your valuable time and words of knowledge you have shared with all of us regarding artificial intelligence. Now, I would like to request Organizing Secretary of this conclave, Dr. Abhishek Chaube, sir, for vote of thanks.
First of all, this is a wonderful lecture given by Dr. Shival Dubey, sir. And I extend my heartily gratitude to today's speaker, Dr. Shival Dubey, Charles University, Czech Republic, for sharing his fantastic information and useful and knowledgeable presentation with us. By this lecture, we learn about the use of AI in smart transportation system and also in automotives. My sincere thanks to all the participants for being with us. I'm sure you will get lots of knowledge related to use of AI in transport vehicle or transport facilities, and also as well as an automobile from this session. So thank you all. Thank you, sir. Shivam.
Thank you, Dr. Chaube, for these kind words. In the last, if I can say, I'm very much open to extend my support to all the students for your institution. If they want any information, you have my contact details, my email IDs and other contact details. So you can share that with the students. I did not share because this streaming is live on Facebook or something like that.
Yes.
So on offline, you can share those details with your students. They can talk to me regarding their projects. If I can help something from here, I'll very much glad to do that. I'm very much into the projects, various projects on AI, and if I can help your student, that will be wonderful for me. Thank you.
Okay, sir. Thank you, sir. Thank you.
Thank you, sir. Thank you, everyone, for joining us for this session. Thank you, everyone.
Okay, sir.